Work and Energy. Part 1. Scientific Concept of Work. In this video, we will get an introduction to the scientific concept of work. Imagine you just completed your homework for the day and suddenly you hear someone say that you have not done any work. The term work has different meanings in our daily life and in science. What exactly do you think work is? Let's discuss some instances which we think of as work, but science considers it as work not done. You try to push a car, but the car does not move an inch. You might say that you have worked hard to displace the car, but according to science, no work is done here. Now, suppose you are rowing a boat or you are swimming in a river. In these cases, both you and science would consider it as work done. In our daily life, we consider both mental and physical effort as work, but science defines work quite differently. Earlier, we looked at a lot of activities that we consider as work in our daily life. Now, can you answer a few questions about those activities? Who is doing the work? What is the work being done on? What is happening to the object? Now, let's have a look at a situation that science considers as work. You kick a football. Your work is done as you are applying force on the ball and it is being displaced. In this situation, there are two conditions that need to be fulfilled for the work to be done. 1. There should be a force acting on the object. 2. The object must be displaced. If any of the two conditions are not met, work is not considered to be done according to science. Now, can you think of some situations from your daily life where work can be considered done according to science? Let us perform a simple activity and derive the mathematical formulae for work done. In this activity, we will consider the force acting on the object is in the direction of displacement of the object. Take a wooden block and place it on a table. Let a constant force F be applied on the wooden block. Let the wooden block displace through a distance S in the direction of force. Let the work done here be W. Here work done W is equal to force multiplied by displacement, which is equal to F multiplied by S. Therefore, work done on an object is equal to the magnitude of the force multiplied by the distance moved in the direction of force. Work has only magnitude and no direction. The SI unit of work is Newton meter, which is called joule. What do you think would be the total amount of work done when force applied is 0 or when the displacement of the object is 0? Do you think work done is always positive, or is there something like negative work? Now, let us consider some examples to see if the work done is always positive or not. Imagine there is a wooden block kept horizontally on a table and a string is attached to the block. Here, the displacement of the block is along the direction of the force applied. Now, we pull the string. The work done in this case would be force multiplied by displacement. In this situation, work done is positive. Suppose a car is moving from left to right with a uniform velocity. Now, we apply a retarding force in the opposite direction, that is, from right to left. There is a 180-degree angle between the direction of motion and the direction of force. In this situation, the work done is considered as negative. The work done may be F multiplied by minus S or minus F multiplied by S. Therefore, we can say work done can be negative or positive. Work done can be negative when the force acts opposite to the direction of displacement. And work done can be positive when the force acts along the direction of displacement. Now, take a look at this coolie carrying luggage. What do you think is the amount of work done by him against gravity? Here, the force acts perpendicular to the direction of displacement. In such cases, the work done is zero. In this video, we got an introduction to the scientific concept of work. In the next video, we will learn about kinetic energy.